guys how to do the determinant on a 2 by 2 matrix. Now I'm going to show you how to do it on a 3 by 3 matrix. And it actually kind of uses this, and just so that we can be using fancy terms, a 3 by 3 matrix is called a third order matrix, and so it's a third order determinant. Okay, so we're going to use fake numbers again. And we're going to say A, B, C. Okay, so we have a 3 by 3 matrix, and we have to find the determinant of it. What we're going to do is we're going to take each of these letters in the top row, right, and when we're actually doing math, it'll be numbers, and we're going to multiply it times the minor, which is what you form when you take out the row and the column that you're looking at. So you end up with a little 2 by 2 matrix. So we're going to multiply the number that either A, B, or C times whatever is left when we take out that first row and that first column. I know it sounds kind of weird, but let's just go through it, okay? So when we do it, we're going to use this guy plus, this guy minus, this guy plus. So that's easy because they're alternating, right? So the first guy I'm going to do is A. Then all of A is multiplied by what's left when I take out the row and the column of A. So that leaves E, F, H, I. Now remember, B is minus. And again, I'm going to take out the row and the column of B. So that's going to leave D, F, G, I. And then C is plus. And what do we have left when we take out the row and the column of C? D, E, G, H. Okay, so D, E, G, H. And that is the determinant of this 3 by 3 matrix. What do we even care about this determinant for? Well, we're actually going to use them to do more calculations. So you have to use the determinant to find the inverse, and the inverse is what's going to help you solve equations. Okay, so this is just another tool for solving these equations that have lots of variables in them. Okay, we are going to start with just a 2 by 2 matrix, which means we're going to have an equation, 2 equations with 2 variables in them. And that'll take like 5 seconds, and then we're going to do the 3 by 3, which means we have 3 equations with 3 variables. So for that, we're going to need to erase this, but you guys have already written it down. And I'm going to tell you guys what the inverse is, because that's what we're actually going to have to multiply. So the inverse is just going to be the determinant times okay, so it's basically the determinant times multiply those, subtract those. Okay? Now we still have D, negative B, negative C, A. So this is our inverse. Now I'm going to show you guys how to use it. We're going to do an example with just 2 variables. Now if you look in your book in those sections that are like sparsed out throughout the book, I'm sure there'll be more examples, and you have a ton of examples in your packet. But I want to give you one example of a 2 by 2, one example of a 3 by 3. So for a 2 by 2 matrix, we have this equation. And then we have 2x minus y equals 0. So we want to turn this into a matrix. The way we do that is actually probably the simplest thing we've done so far. We take the numbers in front of the variables. Okay, then we put the 2 variables, and then we say equals the answers. Okay, so there you go, problem solved. Now, we're just writing it as a matrix, but that's actually not an answer, right? That's just a way of rewriting it. Now I'm going to show you guys how you find an answer. So I need to find the inverse of this matrix first. Okay, how do we find that? We need to get the determinant and multiply it by this part. So I'm going to do the 1 over 8 times D. So that's 3 times negative 1. And then we subtract B times C, which is 1 times 2. And we could do all that math in our head, but we're writing it down so that we can come back and look at it and know what it is that we were doing, right? And then here we're going to put negative 1. Then we make B negative, so it becomes negative 1. We make C negative, and we bring A down here. So that is our determinant, right? Well, that's our inverse, sorry. We can go ahead and take this down to just a simple fraction. 3 times negative 1 is just negative 3. minus 2, so that's negative 5, right? I'm going to go ahead and replace this part with negative 5. So we calculated the inverse. What are we going to do with that? Well, if you remember, I might have been in the first chapter, we went over properties, and one of them was the inverse property. And what was the property of it? When you multiply anything times its inverse, you get 1. And that's kind of a helpful number to have, right, when you're trying to solve equations. So that's why we wanted to find the inverse. We're going to multiply everything in here times the inverse, and we're going to be able to get an answer. I'm going to do it in parts, because I think it's just easier. We'll combine everything, okay? So the first thing I'm going to do is multiply the inverse times this first part of our matrix, okay? So I'm going to say 1 over negative 5 times, let's just write this one, negative 2, 3, and 3, 1, 2, 1, negative 1. Sorry. Okay, now, if this was adding or subtracting, it would be really easy, because remember, for adding or subtracting, you just do first row times first column, first row, first column. First row, second column, first row, second column. But we're multiplying. So what do we have to have? Number of columns in the first one, that's 2, equals the number of rows in the second one, also 2. So at least we know we can solve it. But now we have to solve it. I'm going to start down here. I'm going to leave the 1 over negative 5 till the very end. And I'm going to start solving. So we want this number. What do we have to do? I have to multiply my first row times my first column. Then I have to multiply my first row times my second column, okay? So, first number in the first row is negative 1 times 3. Then I do plus negative 1 times positive 1. Okay? So, that's my first row, first column. Now I'm going to move on to first row, second column. So, I do negative 1 times 1. And then I do negative 1 times negative 1. Okay, so first row, first column, first row, second column. Now I'm going to move on to second row. Same thing, second row, first column is just going to be negative 2 times first column, so 3. And then I'm going to have first row, first column, 3 times 2. Now on this side I'm going to have second row, second column. So second row, negative 2 times 1 plus 3 times negative 1. And that's going to be my matrix. Let me just check the numbers before we solve it. And we have negative 1 times 3 times 2. Inverse is negative 1, negative 1, negative 2, 3. So I did first row, first column. Yep, so, sorry. First row, first column, and I don't know why I did a 1 here. That should have been a 2. And then I have negative 1, 1. Yep. Negative 2, 3. 3, 2, negative 2, 1, 3, negative 1. Alright, so now we're just going to do the math real quick. We're just going to leave the 1/5 out here. So that's going to go to 1 over 5, remember that's negative. And now we should be able to come up with a matrix. Negative 1 times 3 is negative 3, plus negative 2 is negative 5. Now, you're going to notice something that starts happening here. It'll happen in the 3 by 3 also. Negative 1 times 1 is negative 1. Negative 1, is it times negative 1? Hold on. Times negative 1, yeah, sorry. Negative 1 times negative 1 is positive 1. So what's negative 1 plus 1? 0. Now we have negative 2 times 3 is negative 6, plus positive 6, another 0. Now we're going to have negative 2 times 1 is negative 2, plus negative 3 is negative 5. Now these two -5s are a coincidence, but the zeros going down like that, that's what you're gonna find every time. If you did it right, you should end up with numbers going straight down the diagonal. So AD, or if you have a 3x3 matrix, this letter also, and all the other ones should be 0. So we know that we did this right. We multiplied this guy times the inverse. Well, now we have this guy that we want to multiply times the inverse. But before that, let's go ahead and multiply this times your scalar. Remember, you just multiply every number in there by it. So that's just going to equal -5 times 1/5 is 1. 0 times -1/5 is 0. 0 times -1/5 is 0. And -5 times -1/5 is 1. So that's exactly what your answer should look like. You should end up with 1s across the diagonal, 0s everywhere else, once you've multiplied by any scalars. So here it was okay because we hadn't multiplied it by the scalar yet. Okay? So we have this side multiplied by the inverse, but remember you have to multiply both sides of the equations by everything, or you're changing the values. So now we have to multiply this guy times the inverse, and I think I'm gonna have to erase some stuff. So let's erase this side. Let's not erase the inverse because we need that, but let's erase all of this. I'm gonna leave that because that's what we ended up with, right? So now we're gonna multiply this times 5, 0. This time it's gonna be a little bit easier. Now before we multiply, let's remember, number of columns in the first one, 1, 2. Number of rows in the second one, 1, 2. So we can multiply. Let's leave the 1 over -5 out here, and let's multiply. First row, first column, -1 times 5, plus -1 times 0. That's what's going to go in your first row, first column. First row, second column. Well, there's not a second column, so we're not doing that. Second row, first column. -2 times 5, plus 3 times 0. So it's going to be 1 over -5. And what do we get? -5 plus 0 is just -5. -10 plus 0 is -10. Multiply that times this, and we get -5 times -1/5 is just 1. -10 times -1/5 is just 2. So now we have our two matrices that we ended up with. Let's plug them back into here. We get 1, 0, 0, 1, x, y equals 1, 2. Now, you could multiply all this if you didn't believe me, or you can just believe me. This one has a 1x equals 1. 1y equals 2. So what are your values, your answers? X equals 1, y equals 2. So you solved your system of two variables with a matrix. Was that any faster than just substituting? I don't think so at all, and that's why I don't love matrices. But it is another way to do it, and some of y'all might enjoy it, some of y'all might be gluttons for punishment. I showed you guys how to do it. So that's systems of two variables. But we gotta do 3 variables, and this one is gonna take the whole board. All right, so I am going to rewrite what our determinant was for a big old 3x3. So if you have A, B, C, D, E, F, G, H, I, then your determinant is going to be So what's your determinant going to be? Let's go back to the beginning. You have to multiply every number in that first row times, it's called a minor, whatever's left if we take out that row and that column, right? So we get A, E, F, H, I. Remember we subtract the second one. D, F, G, I, and then we add the C times D, E, G, H. Okay, that's your determinant. So, now, the determinant is what we're going to use to calculate the inverse, which is what we're going to use to solve a system of equation, okay? So, for 3 by 3 matrix, we use Kramer's rule. So we have to calculate the determinant, make sure it's not 0. So we have to actually calculate the value of this determinant, make sure that it's not 0. If it's 0, can't do matrices, but first you have to do all this math to figure it out. And then we do this, it's not as complicated as it could be, but it is complicated. So in order to test this, we have to use an equation, so I can show you how it works, okay? I'm going to write down our problem way over here, so we have lots of room. We have x plus y minus z equals -2. And then we have 2x minus y plus z equals 0. And then we have x minus 2y plus 3z equals 1. Okay, so we have to calculate the determinant for this only to make sure that it's not 0. So let's figure it out. Let's write this down as a matrix first. 1, 1, -1. 2, -1, 1. 1, -2, 3. I'm going to go ahead and write the x, y, z here so we have it for later, because obviously as it is the example, it's not going to equal 1 or I wouldn't be able to teach you much, would I? So let's plug all these numbers into this, make sure we don't get 0. What's a? 1, right, times -1, 1, -2, 3. Then we do minus 1, and we get 2, 1, 1, 3, plus -1, 2, -1, 1, -2. There you go. That's what we have to do for our determinant. So, how are we going to solve it? We are going to get the number outside, and we're going to multiply it times that minus that. Okay, we did that just a second ago in the 2 by 2 determinants, so let's just do it real quick. So we do 1 times, hold on. Yep. What's 1 times negative? -1 times 3 is -3 minus -2 times 1, which is -2. Okay? Now, we have the second one, which is -1 times 2 times 3, which is 6, minus 1 times 1, which is 1. Last one, plus -1, so I'm just going to make it -1, times 2 times -2, which is -4, minus 1 times -1, which is -1. So we have 1 times -3 plus 2, which is -1, minus 1 times 6 minus 1, which is 5, minus 1, remember it was just minus a negative, plus a negative, so we made it minus, times -4 plus 1, which is -3. Let me check those numbers before we go further. Okay, -1 times 1 times -1 is -1, minus 1 times 5 is 5, minus, sorry, 1 times -3.
Should I check on it?
No.
Okay.
Which is minus -3. So that's -1 minus 5 is -6 plus 3 is -3. Which is not what I got. Let's check our math. It's not 0. Oh no, it is -3. Sorry, that's what I got. So it does actually, even if I had made a mistake, it doesn't technically matter at this point because you just have to make sure you didn't get 0. So -3 is not 0. So what did we do all this for? Only to find out that we actually can use matrices to solve this equation. So this doesn't actually help us get the answer. But you have to do it. Because if not, you're going to go through all the work of finding the answer and you may find out, wonk wonk, that you couldn't use it. So now we're going to use what's called Kramer's rule and we're going to find x, y, and z. So the way we're going to do that is We're gonna find determinants, but how are we gonna find them? To find the x determinant, we're gonna replace the column of x with your answers. To find the y determinant, we're gonna replace the column of y with your answers. And to find the z determinant, we're gonna replace the column of z with your answers. So it's pretty cool that it works, and I'm sure there's a long old proof somewhere as to why it works. I still think using substitution is a lot easier, but I think there's programs that can solve this for you. So if you were doing that, I guess this is a lot easier. So we're gonna calculate the determinant. Before we do that though, I'm gonna rewrite the matrix. So remember, for x, I'm replacing the column of x, which is the first one, with the column of the answers. 2, 0, 1, everything else stays the same. 1, -1, -2, -1, 1, and 3. So we're doing the determinant for this. How do we do the determinant again? Multiply this guy times those. We multiply that guy times those. Then multiply the last guy times those. Okay? So let's do the math over here. This is our first guy. 2. What I'm going to do is go ahead and set us up -1 plus -1. And then we're going to solve these. Okay? So it's 2 times, remember we take out that row and that column. -1, 1, -2, 3. Let's move this a little closer so we have more room. -1, and then we multiply it times what's left there. 0, 1, 1, 3. And if you're doing this on a piece of paper and you have a ruler or something, you can just put the ruler kind of there to block it. On the board it's a little bit harder to do. And our last one is plus -1. And again, we take out that row, that column. So we end up with 0, -1, 1, -2. Now we're going to find the answer. Multiply this times the product of those minus the product of those. So we do 2 times -3 minus -2, right? Product minus product. Then we do -1 times 0 minus 1, and then -1 because it's plus a negative. Doesn't matter what we're multiplying because it's 0, -1. So we will get 2 times -3 plus 2, which is -1, minus 1 times 0 minus 1, which is -1, minus 1 times 0 minus 1, which is again, sorry, doing the parentheses on the outside, so let's do minus 1 times -1. Okay, let me check those numbers. 2 times, well, let's see, 2 times -1 is -2. 1 times -1 is -1, you're subtracting a negative, so you're adding it. 1 times -1, again, you're adding. So we should get 4, but I don't think that's what I got. I got 2. So let's just make sure my math is right. We have -2 let's check our numbers. This number was -2 from up here. So that was -2. That was -2. So it would have been -2 times, sorry about that guys, it would have been -2 times, that which would have been -2 times -3 plus 2, which is 1. So that would have been 2, and then we would have ended up with -1 times 0 minus 1, yep, -1 times 0 plus 1, because it would have been 0 minus -1. So it would have been 2 plus -1 minus 1, which is just 2. Sorry for the confusion on the math. You can go back and check it though. So it's 2 plus 1 minus 1, which is just 2. What do we do with that 2? That's actually our answer for x. So 2 equals x. I'm going to write that over here, or we don't have to erase it. So now we're going to do the exact same thing to find y. Now I know that my third column is going to be the same, so I don't have to rewrite it. My first column I keep, which is 1, 2, 1. Then remember the y column gets replaced with the answer column, which is -2, 0, and 1. And then we do the whole thing again. So we're going to take this first number, 1, then we're going to multiply it times what's left, right? 0, 1, 1, 3. Minus, then we do -2. We have 2, 1, 1, 3. And then we do plus -1 times. We have left 2, 0, 1, 1. Alisa, will you make sure it's still recording?
Yeah.
So this is going to equal, remember, the product of that minus the product of that. 1 times 0.
It's still recording.
Perfect.
And
Minus
apparently
1.
it's not limited to 15 minutes because
Okay.
it has
Good,
26.
thank you. So 1 times -1. Now, minus a negative, so that's plus 2 times 2 times 3, which is 6, minus 1 times 1. Now we have our last one, plus -1, which is just -1 times 2 times 1, minus 1 times 0, so 2 minus 0. That's going to equal 1 times -1 plus 2 times 5, sorry, parentheses on outside, minus 1 times 2. So do you see how I got that? That's 1 times 0 minus 1 is -1. 2 times 6 minus 1 is 5. -1 times 2 minus 0 is 2. So what does that give us? 1 times -1 is -1. 2 times 5 is 10. 2 times 1 is 2. So it's -1 plus 10 minus 2. -1 plus 10, -9, minus 2, -7. See if that's what I got. That is what I got. Except, sorry, it's positive 7. -1 plus 10 is positive 9, minus 2 is positive 7. So I'm going to write that up here. That's our answer to y. Now all we have left is x. Now, if you weren't doing a section on matrices, but you felt like doing matrices and you'd already found x and y, you could just plug them into one of these equations to find z, right? But we're not taking any shortcuts. We're not taking the easy way out. We're doing another matrix. So the third row and the second row are going to change now. Second column comes back down, 1, -1, and -2. And remember, we're finding z, so we're going to replace the z column with the answer column, which is -2, 0, 1. And we do the same thing. So we have 1 times -1, 0, -2, 1. Then we have -1 times 2, 0, 1, 1, plus -2 times 2, -1, 1, -2. So we do 1 times -1 minus -2. Then we do -1 times, that's 2 minus 0. Then we do plus -2 is just -2. And then we do 2 times -2, which is -4, minus -1. So we get -1 plus 2 is 1 times 1, 1. Then we do minus, well, let's not skip any steps. Let's do 1 times 1 minus 1 out here times 2 minus 2 times -4 plus 1, which is -3. So that's going to go to 1 times 1 is 1, minus 1 times 2 is 2, minus 2 times -3, -6, which is just plus 6. So 1 minus 2 is -1, plus 6 is 5. Let me see if that's what I got. No, I got 3, so just give me a second. 1 minus 0, this should be 0. Oh, this is 0, guys. What's 0 times -2? 0. So this is actually -1 minus 0, which is -1. So the answer to this is -1. -1 minus 2 is -3 plus 6 is 3. So we found our z value. Except we're not 100% done. Now we have to divide everything by our determinant. So remember that first determinant that we found? I already erased it, but you guys have it written down. We found the determinant of the whole thing, and I believe it was -3, but I'm gonna go back into my notes, and it was -3. So now we have to divide each of the answers we found by -3, which now it makes sense why our determinant can't be 0, right? Because anything divided by 0 is undefined. Remember when we were finding answers and they were extraneous friendly? That's because they were divided by 0. So if our determinant is 0, we get 2 over 0. That's not an answer. That doesn't work. In this case, we get 2 over -3. Y equals 7 over -3. And z equals 3 over -3. Now, we're going to test this real quick just because that was a lot of math and we want to be sure. But I'm going to test it right here because that's the easiest one to test it in, okay? So I'm going to get x, which is 2 over -3, plus y, which is 7 over -3, minus z equals 2. Now, we have the lowest common denominator, so we can just add all the numerators. 2 plus 7 is 9, minus 3 is 6. Sorry, -2. So we get 6 over -3 equals -2, and that is a true statement. Which means that all that work proved to be helpful. Now, as you noticed, I made mistakes in there, but I had already done it once, so I could check my answers. And when I did it this time, I was following a lecture or something online, so I could check my answers. So you want to go really slow, and I would check my answer every time instead of doing all the math and then figuring out you did something wrong, because it's really easy to make mistakes. So that is the end of matrices. I hope you took your time and you didn't just sit down and watch all this, because that would have been super boring. And now you have a packet to do. Go back and look at these as much as you want. That packet will count as a test grid. I'm not going to give you guys a long